They brought back moon rocks, scanned its core, and found frozen water. What we now know about the moon will blow your mind. The story of the moon didn't begin quietly. According to the most widely accepted scientific theory, the moon was born out of chaos, a colossal cosmic crash. Over 4 billion years ago, Earth wasn't the calm blue planet we know today. It was still young, hot, and constantly bombarded by massive space rocks. Then came something even more dramatic. A Mars-sized object scientists call Theia slammed into Earth. It wasn't just a hit, it was a full-speed collision that changed both worlds forever. The impact didn't destroy Earth, but it did send a huge cloud of molten rock and debris flying into space. For a brief moment, Earth had a glowing ring of fire around it, not unlike the rings of Saturn, but made from our planet's own guts. That material didn't just drift off. It started to clump together, held by gravity, and began forming a brand new celestial body, the Moon. This theory explains why the Moon's composition is so similar to Earth's outer layers. Scientists have compared the isotopes in moon rocks brought back by the Apollo missions and found striking similarities. The Moon isn't just Earth's neighbor. It's more like its twin forged from the same molten beginnings. Interestingly, the Moon we see today didn't form instantly. After the impact, it would have taken days, maybe weeks, for the debris to settle and begin shaping into a sphere. And that sphere would have glowed red hot for millions of years before cooling down. It was likely closer to Earth at first, much closer, looming much larger in the sky. Tidal forces eventually pushed it farther out to where it orbits now, about 239,000 miles away. There are other theories, of course. Some suggest the Moon formed elsewhere and got captured by Earth's gravity. Others claim Earth and the Moon formed side by side. But none of those theories line up with the chemical fingerprints found in lunar soil. The giant impact hypothesis still holds strong, because the pieces fit literally and scientifically. At first glance, they might not seem that special, gray, dusty, and worn. But under a microscope, they tell a story that spans billions of years. Lunar rocks are like time capsules. They've been untouched by rain, wind, or biological life. No erosion, no plant roots, no water running over them. In fact, some of the rocks are older than any rocks found on Earth's surface. One of them, nicknamed the Genesis Rock, is over 4.4 billion years old, practically from the time the Moon itself formed. Most of the moon rocks fall into three main types: basalt, breccia, and anorthosite. Basalts are volcanic rocks, evidence of ancient lava flows that once oozed across the Moon's surface. Breccias are a wild mix, formed from impacts, shattered pieces, fused together under intense heat and pressure. And anorthosite? That bright white rock that reflects sunlight so well it forms the highlands, and is thought to be the Moon's original crust. Thanks to these samples, scientists discovered that the Moon was once volcanically active. Some of the basalt flows date back billions of years, hinting at a time when molten rock welled up from within and spilled across massive plains. These plains, known as lunar maria, are what form the dark patches we can see from Earth with the naked eye. But the moon rocks didn't just reveal the Moon's history, they helped unlock Earth's too. Isotope comparisons between lunar and terrestrial rocks showed a near-identical signature, supporting the idea that both Earth and Moon share a common origin, likely from the same planetary body after a giant impact. Even today, decades later, scientists are still analyzing tiny fragments from the Apollo samples. New technologies like scanning electron microscopes and mass spectrometers allow for more detailed investigations than ever before. Researchers have even found traces of solar wind particles embedded in the dust, direct physical evidence of the sun's influence. Stored for eons in lunar soil. Beneath the silent gray surface of the Moon lies a world we can't see, but one that scientists have spent decades trying to understand. It might seem like a dead rock drifting through space, but the Moon holds surprising layers within. And recent studies have revealed that its interior is far more complex and dramatic than once thought. The Moon has a crust, a mantle, and a core much like Earth. But its core is smaller and less active. NASA scientists, using data from seismometers left by Apollo astronauts, discovered that the Moon's core is partially molten. It's about 300 miles wide, surrounded by a fluid outer layer and a solid inner core. That inner core, according to a 2024 reanalysis using artificial intelligence, might be almost entirely made of metal and shockingly similar to Earth's, just scaled down. There's more. Underneath the surface, deep in the mantle, scientists have detected dense, metal-rich structures, possibly fragments of the early Moon's chaotic formation. Some believe they could even be leftover pieces of Theia, the mysterious planet-sized body that may have collided with Earth to form the moon. These ultra-dense masses might help explain something that's long puzzled researchers: the moon's gravitational lumps, or mascons, short for mass concentrations, that subtly tug at spacecraft and alter their paths. In 2023, thermal mapping of the moon's interior suggested heat is still leaking out from deep below, especially beneath certain craters. That led to a flurry of speculation, some of it based in science, some not. One of the most viral claims came when a satellite image, like the one you've seen in this video's thumbnail, appeared to show strange golden-hued formations in an ancient crater. Social media exploded with rumors. Was there gold beneath the moon's surface? Were mining companies already planning missions to claim it? The truth, of course, is less flashy but still fascinating. The glow in those images wasn't gold, it was a combination of mineral reflectivity and lighting angles during lunar sunrise. However, there is a high concentration of rare elements in certain regions, including thorium and uranium. And some areas have an unusually high density of titanium, which would be valuable for future moon construction projects or resource harvesting. The idea of a lunar gold rush might be more fantasy than fact for now, but the interest it sparked reveals just how little we still know about what's hiding underground. And that's exactly why upcoming missions from NASA and other space agencies are focusing not just on the surface, but on drilling deeper. For most of human history, half of the moon remained invisible. Because the moon is tidally locked with Earth, it shows us only one face, the same face, every single night. The other side, often wrongly called the dark side, remained a total mystery until 1959, when the Soviet spacecraft Luna 3 snapped the very first grainy photos. What it revealed surprised everyone. Unlike the side we see from Earth, dotted with smooth, dark plains called Maria, the far side was a jagged, cratered wasteland. It looked older, harsher, and much less forgiving. That difference puzzled scientists. Why would one side be so different? Later research offered a clue. The Earth-facing side of the moon has a thinner crust, which allowed lava to rise and spread out after ancient impacts, forming the Maria. The far side's crust is thicker, so when meteors slammed into it, the molten rock couldn't break through. The result? No smooth seas, just pitted highlands. The biggest scar on the far side is the South Pole Aitken Basin, one of the largest impact craters in the solar system, stretching over 1,600 miles wide. It's so deep that it may have punched all the way into the moon's mantle. China's Chang'e 4 mission, which landed there in 2019, gave us an even closer look. It confirmed the presence of unusual minerals, possibly from beneath the crust, raising the possibility that this massive impact exposed material from the moon's interior. So the far side isn't darker, it's just unexplored territory, still holding secrets that may reshape what we know about the moon's origins and evolution. And now with new missions on the way, we're finally beginning to listen to the half that stayed silent for so long. If you walked on the moon without a spacesuit, you'd die in seconds, not because of freezing temperatures or cosmic radiation, but simply because there's no breathable air. But that doesn't mean the moon is completely empty of atmosphere. Technically, it does have one, just not the kind we're used to. Scientists call it an exosphere, and it's incredibly thin. So thin, in fact, that the number of molecules in a cubic centimeter of space would barely register about 100 molecules or fewer. By comparison, Earth's atmosphere contains roughly 10 billion molecules in the same space. That's why we often say the moon has no atmosphere at all, it's close enough. Still, what little it does have is fascinating. The moon's exosphere is made of trace elements like helium, sodium, and even potassium. These elements aren't held in place by gravity in the way Earth holds its air. Instead, they're released by solar radiation, micrometeor impacts, and radioactive decay from the moon's interior. Then they drift away into space within hours or days. In 2024, India's Chandrayaan-3 mission confirmed fluctuations in sodium emissions near the moon's surface, especially during solar storms. These spikes revealed how fragile the lunar exosphere is and how solar activity can shape it. NASA also discovered that water molecules might briefly exist in the exosphere during lunar daytime, vaporized from the surface by heat and sunlight. At night, when temperatures plunge, they freeze again or vanish. So yes, there's something up there, but calling it air would be like calling a fog a flood. It's barely detectable, yet still full of clues about the moon's interaction with space, the sun, and even Earth itself. For decades, scientists believed the moon was bone dry. Then came a discovery that changed everything: frozen water, hidden in shadowed craters near the poles. And not just traces, there could be hundreds of millions of tons of it, buried in regions that never see sunlight. The key to this discovery came from NASA's L-Cross mission, which in 2009 crashed a probe into a permanently shadowed crater near the moon's south pole. Instruments detected water vapor and ice fragments from the blast. Since then, both NASA and the Indian Space Agency ISRO have confirmed similar findings using infrared imaging and spectrometry. So where does this water come from? Some of it likely arrived on comets and asteroids that slammed into the surface billions of years ago. But there's also a good chance some was formed on-site, created when solar wind hydrogen collided with oxygen-bearing minerals in the lunar soil. These icy reserves are more than a scientific curiosity, they're a game-changer. Future moon bases could use this frozen water not just for drinking, but to generate breathable oxygen and rocket fuel through electrolysis. A moon colony could become self-sustaining, launching missions deeper into space without needing constant supplies from Earth. But there's a catch. These frozen craters are some of the most difficult places to reach. Temperatures plunge below -250 degrees Fahrenheit. There's no sunlight, no line of sight to Earth for communications, and the terrain is treacherous. Still, multiple countries are racing to get there. NASA's Artemis program, China's lunar landers, and private companies all have plans aimed at the poles. Because where there's water, there's potential for survival, for exploration, and maybe one day, for industry. It might not have roaring volcanoes or shifting tectonic plates like Earth, but the moon isn't entirely still. Beneath its ancient surface, the moon shudders, and sometimes it rumbles hard enough to crack rocks open. These are called moonquakes, and they come in several types, each revealing something different about what's happening under the surface. Some moonquakes are caused by temperature changes. The moon goes from boiling hot in the day to freezing cold at night, creating stress that causes the surface to creak and pop. These are minor and fairly harmless. Others come from meteorite impacts or tidal forces from Earth's gravity. But then there are the deep moonquakes, the ones that originate up to 700 miles below the surface. Detected by seismometers placed during the Apollo missions, some of these quakes can last up to 10 minutes. That's far longer than most quakes on Earth. What's causing them? Scientists believe it's the gravitational tug-of-war between the Earth and the moon. As the moon's orbit changes slightly over time, stress builds up and releases in these long, slow jolts. Even more mysterious are shallow moonquakes. These come from only a few miles beneath the surface, and they can be surprisingly strong, up to magnitude 5 on the Richter scale. That's enough to knock over equipment or damage a habitat. Some of them happen near fault lines, which may still be slowly shifting as the moon cools and contracts. In fact, NASA's Lunar Reconnaissance Orbiter found evidence of fresh fault scarps ridges that form when the surface buckles, suggesting the moon is still shrinking, even now. Understanding these quakes isn't just academic. If humans are going to build permanent structures on the moon, we need to know what's moving under our feet. Because even in a place with no weather, no tectonics, and no life, the ground still trembles. Today, the moon has no global magnetic field. A compass wouldn't work up there. But billions of years ago, things were very different. Ancient moon rocks reveal a surprising truth. The moon once had a magnetic field nearly as strong as Earth's. So what happened? Scientists believe the moon's core was once molten and active, just like Earth's. As the molten iron flowed, it created a dynamo, a natural magnetic generator. That field likely lasted for several hundred million years, shielding the lunar surface from solar radiation. But eventually, the small size of the moon became its weakness. It cooled too quickly. The flow inside the core slowed, then stopped, and the magnetic field faded away. The strongest magnetic signals found today come from specific areas in the moon's crust. These magnetic hotspots are leftover relics frozen in place when lava cooled during the moon's early magnetic phase. Some are so powerful they even interfere with modern spacecraft instruments. In 2025, advanced simulations using Apollo rock data confirmed that this ancient magnetism peaked around 4 billion years ago before slowly declining. The moon's once powerful field eventually faded into silence. Still, its traces remain, locked in stone. And these magnetic fingerprints do more than tell us about the moon. They help scientists understand how planets form, how their cores behave, and what might be possible on other rocky worlds. Even Mars shows hints of a lost magnetic past. The moon's magnetic history is like a ghost invisible today but recorded deep in its surface, reminding us that even silent worlds were once alive inside. Lunar dust may look soft and powdery in photos, but don't be fooled, it's one of the most dangerous substances on the moon. This fine gray powder is known as regolith, and it's nothing like the dirt on Earth. Because there's no wind or water to smooth it out, lunar dust is sharp. Every grain is like a microscopic shard of glass. It clings to everything: spacesuits, tools, equipment. Apollo astronauts said it got into joints, scratched visors, and even smelled like gunpowder when brought into the lander. And then there's the health risk. The grains are so tiny that if inhaled, they could lodge in the lungs and never come out. Some scientists compare it to breathing in powdered glass or asbestos. During the Apollo missions, astronauts reported coughing, sneezing, and irritation after being exposed for only a few hours. In 2024, tests using simulated lunar dust on Earth confirmed that long-term exposure could cause serious health issues, especially in enclosed environments like moon bases. That's why NASA is now working on special filters, dust-repellent fabrics, and airlocks designed specifically to keep the dust outside. Even the surface itself is a challenge. Regolith can be deceptively loose, wheels sink, legs tip, and landers can kick up huge clouds of it during descent. That dust cloud can coat nearby instruments or reflect enough sunlight to throw off sensors. If humans are going to live on the moon, we'll need to master the dust. Because up there, it's not just dirt. It's a silent hazard, one that hides in plain sight and could make or break long-term survival. Hidden beneath the moon's surface lie long, winding tunnels, remnants of ancient volcanic activity. These are lunar lava tubes, and they might be the best hope we have for building future bases beyond Earth. Billions of years ago, the moon was volcanically active. Rivers of lava flowed across its surface. As the top layers cooled and hardened, molten rock continued to flow underneath, eventually draining away and leaving behind hollow tubes, some stretching for miles. Why do these tubes matter now? Because they offer natural shelter. The moon's surface is bombarded by solar radiation, hit by micrometeorites, and swings between extreme temperatures. But inside a lava tube, it's quiet, stable, and protected. Temperatures are more consistent, and there's shielding from both cosmic rays and the threat of quakes. Some of these caves are massive. Based on radar scans and satellite imagery, scientists believe some could be wide enough to fit skyscrapers inside. In fact, Japan's Kaguya spacecraft detected a 50-foot wide entrance leading to what might be a tunnel hundreds of feet deep. NASA and international space agencies are already looking at these tubes as possible sites for habitats. Robots could explore them first, followed by crews who would set up inflatable shelters or even use 3D printers to build habitats using lunar soil. And if that sounds like something out of The Expanse or Interstellar, it's not far off. These natural caves could be the foundation of real-life lunar cities, places where humans could live, work, and study in safety, deep inside the moon itself. The moon isn't just a distant rock in the sky, it actually shapes life on Earth every single day. Its gravitational pull is responsible for the tides. But, its influence runs even deeper than most people realize. Every time the tide rises or falls, it's because of the moon. Its gravity tugs at Earth's oceans, creating bulges that move as the moon orbits. This constant motion affects marine life, weather patterns, and even Earth's rotation. In fact, the moon is slowly slowing us down. Our days are getting longer by about 1.5 milliseconds every century. But here's the wild part without the moon. Earth might not be so stable. The moon acts like an anchor, helping to keep Earth's tilt, and therefore our seasons from wobbling too wildly. Without it, our planet could tilt dramatically over time, possibly creating extreme climate shifts that would challenge life as we know it. Some researchers believe the moon even played a role in the origin of life. The tidal zones it created, warm, shallow areas that rose and fell with the tides, may have been ideal places for early life to form. Those pools would concentrate chemicals, expose them to sunlight, and then cycle them back again. Even our calendars and myths are tied to the moon. Ancient cultures tracked time by its phases. Music, art, and even band names like Pink Floyd's The Dark Side of the Moon reflect its ever-present influence. So while it may feel distant, the moon is anything but. It's a silent partner in our planet's history, pulling the strings from 239,000 miles away, shaping oceans, guiding time, and maybe even helping spark the first spark of life. For decades, people have claimed to see strange things on the moon domes: towers, lights, even flying objects. Some say there are alien bases hidden in craters. Others point to satellite images with blurry shapes and cry cover-up. But what does the science say? Most of these claims come from low-resolution photos or misinterpretations of natural features. The human brain is wired to find patterns, especially faces or structures. It's called pareidolia, the same effect that makes people see shapes in clouds or figures on toast. When it comes to the moon's shadowy terrain, it's a perfect storm for this kind of illusion. One of the most famous cases is the so-called shard, a tall, thin shadow seen in early lunar photographs. Some believed it was a spire or antenna. Later, better images showed it was just a jagged ridge catching light at a sharp angle. Another popular claim is that lights or flashes seen on the moon must be evidence of alien activity. In reality, they're more likely caused by sunlight reflecting off freshly exposed rock, or even cosmic rays hitting a camera sensor. NASA and international space agencies have mapped nearly the entire surface of the moon with high-resolution imagery. So far, no alien structures, no artificial lights, no mystery bases. Still, the rumors persist, partly because the moon is close enough to watch but distant enough to imagine. It's been used in everything from Transformers' Dark of the Moon to conspiracy videos claiming secret missions. But in real science, the unexplained often has a very Earth-based answer. The moon is mysterious, but its secrets come from geology, not aliens. And the more we explore, the more we uncover beauty in the real over the imagined. Living on the moon is no longer just science fiction, it's actually a real goal. NASA, SpaceX, and other agencies are planning bases near the moon's poles, where frozen water can be mined for drinking and fuel. Inflatable shelters, underground habitats and lava tubes, and 3D printed structures using lunar soil are all on the table. Power will come from solar panels, and rovers will explore while robots help build. The first outposts will be small, but they could grow into permanent bases, the first steps to living beyond Earth. That's about it. Would you like to go to the moon? Write in the comments. For more useful information, watch other videos.